Hey guys, today we're going to do section 5.2 extrema on an interval. So we are approaching what is called curve sketching, where we will be given a function and then we will analyze that function and create a graph based on the information that we have found. So I think you'll find that today's video has quite a bit of information already written on it for you, so that just pausing your video and getting what you need will be kind of the name of the game for this one. So the graph of y equals h of x is shown below. Determine the extrema. And extrema is simply maximums and minimums on the interval from a to f. So there are two types of minimums and two types of maximums. There are relative max and min and absolute max and min. Absolute max and min are the absolute highest and absolute lowest points on your graph. And the relative max or mins are any maximums or minimums that occur in between those absolute values. So here's your absolute highest point and your absolute lowest point. Here's another minimum and another maximum. So f of b is a relative minimum, f of c is a relative maximum, f of d is an absolute minimum. At x equals d, it's your lowest point, and f of e is an absolute maximum at x equals e, which is your highest point. So we got some definitions here at the bottom. Relative or local extrema, y values on the graph of a function where the function changes from increasing to decreasing and vice versa. Absolute or global extrema are the highest or lowest y values on the graph of a function or on a specified domain of the function. We typically use the words relative and absolute, max or min. If there is an open interval containing C on which f of C is a maximum, then f of C is called a relative maximum. If there is an open interval containing C on which f of C is a minimum, then f of C is called a relative minimum. So here's just some added information. When we say an open interval containing C, we mean that we can find some interval AB, not including the endpoint, such that C is between A and B. So C will be contained somewhere inside the interval and will not be either of your endpoints. Relative extrema is slightly different than absolute. We just talked about that. All that's necessary for a point to be a relative max or min is for that point to be a maximum or a minimum somewhere in that interval. And there can be smaller or larger values of the function at some other location, but relative to x equals c. So f of c is smaller or larger than all the other function values in the neighborhood of c. So as you look at example number 2, consider the graph of y equals g of x shown at the right. State the relative extrema of g of x. So let's go ahead and set up relative max and relative min. So our relative max, here's a maximum. It's equal to 2 at x equals 2. And our relative minimum is 0 at x equals 4. So the absolute extrema, because our graph is going to infinity in both directions, the absolute max does not exist. And we call that unbounded. And this would be unbounded above your graph. And then your absolute minimum, your lowest point, is -8 when x is -3. Relative extrema, for example number 3, here's your graph, highs and lows. So we have a relative max at 7, 7. We have a relative min of -2. And we have another minimum of 2 at 10. And then consider your domain, absolute extrema. So we should have an absolute max and an absolute min. 7 at 7. Notice your relative and absolute max and min, or max, are the same, excuse me. And then our lowest point is -2 at 2. So that one is also listed under the relative section. All right. Now we're going to talk about another theorem called the EVT, the extreme value theorem. If f is continuous on the closed interval AB, continuous, the closed interval, then f has both a maximum and a minimum value. Extreme values can occur at interior points or endpoints. A function may have both max and min values, either a maximum or a minimum, or no extrema or an interval. So when the hypothesis is not met, either continuity on the closed or the closed interval, there is no guarantee of the conclusion. Think about that for just a second. So taking a look at these 4 graphs, all right, part A, what do you notice? Not continuous. Part B, not continuous. Part C, open into infinity. So it's not continuous on a closed interval. D, also not continuous on a closed interval. So here's the information that will accommodate what we just said. The EVT does not apply because it's not continuous on 0 to 3 closed. The absolute minimum is at x equals 0, 0 about 1/2, and the absolute max is at x equals 1. For part B, again, not continuous on closed 0 to 3. The absolute max is when x equals 0, and there is no absolute minimum because your lowest point has an open circle. Part C, open circle, which indicates it's not closed. So that means the EVT does not apply because f of x is not continuous. Because it is open, there is no high point. Because it continues to negative infinity, there is no low point. So there is no extrema. In part D, the EVT fails because your endpoints are open, so it's not continuous on a closed interval. It does have an absolute maximum of 4 at x equals 1, and it does have an absolute minimum of probably about negative 1/2, when x is equal to 2. The extreme value theorem gives us the knowledge of when extrema occur, but how will we find them algebraically when given an equation only without the benefit of a graph? So our next question should be, how can we identify all values of x when extreme values occur? So as we look at here at example number 5, we should be able to look at the interval, look at the function, look specifically at the denominator. When is it not continuous? Then think about part B. What kind of function do you have? Look at your interval. Is it continuous from -5 to 5? And then look at part C. You have a square root function. Remember what has to happen for a square root function. Look at your interval. Think about what you know. We should know in part A that the EVT does not apply because f of x is not continuous at 2, and 2 is in your interval from -4 to 4. So x cannot equal 2 here because it would be a vertical asymptote. Part B is actually continuous on all reals, so the EVT does apply on -5 to 5. And for part C, h of x is only continuous for values greater than or equal to -2. Remember, what's underneath the radical must be 0 or positive. So the EVT is not going to apply from closed -6 to 6 because -2 is anything that is less than -2 will make that negative, and -3, -4, and -5 and -6 are all in that closed interval. A critical number or value of a function f is a value x equals c in the domain of f such that either f prime of c equals 0 or f prime of c does not exist. You're going to hear that a lot. If x equals c is a critical value, then CF of c is a critical point. Relative local extrema can only occur at a critical value on an open interval. Absolute extrema must occur at a critical number or at an endpoint. All right, so we're going to look now at example number 6 and how to find extrema if this is the information that we have. So grab your calculators. These problems are going to take just a little bit, but remember, this is all we have. So we have closed from -1 to 2. We're going to start by finding f prime. So 24x squared minus 6x minus 9. We're going to divide by 3, take that 3 out. So 8x squared minus 2x minus 3 is equal to 0. And using our x method to factor, we have -24, -2, and divide by 8. And we have -6 and 4. So that's -3/4 and 1/2. So 4x minus 3, 2x plus 1. So x equals 3/4 and x equals -1/2 are going to be our critical numbers because it's where our derivative is equal to 0. So now we're going to take a chart, x and f of x. We're going to start with our first endpoint, -1. Then we're going to go to our critical point, -0.5, and then 0.75, and then our final endpoint at 2. All right, so we're going to use our calculator to complete our chart. Store -1. And we're going to type in 8x cubed minus 3x squared minus 9x plus 2, and we get 0. And -0.5 store as x, and 8x cubed minus 3x squared minus 9x plus 2, 4.75. 0.75 store as x, 8x cubed minus 3x squared minus 9x plus 2 is -3.06. We'll just call that 3 for sake of space. And then storing 2, 8x cubed minus 3x squared minus 9x plus 2 is 36. Looking at f of x, our minimum lowest value is -3.063, and our highest value, our max, is 36. Feel free to pause the video if you would like to do B through E, or feel free to follow along. G prime of x equals 1 minus 2 cosine x. 1 minus 2 cosine x equal to 0. 1 equals 2 cosine x. So I need to know where cosine x is equal to 1/2 on your unit circle from 0 to 2 pi. That happens at pi over 3 and 5 pi over 3. So we have x and g of x, and we have 0, pi over 3, 5 pi over 3, and 2 pi. And from our chart, we're going to find a minimum and a maximum. So if you would like to, go ahead and pause the video, find your values, and find your min and your max. So your values in your chart are 0, -0.685, 6.968, and 6.283. So our minimum is -0.685, and our max is 6.968. H prime of x, bring down -1 times the derivative of the inside. Take out a GCF. So I need to know where is sine x equal to 0 and where is cosine of x equal to -1/2 on the unit circle. So 0 and pi and 2 pi and 4 pi both are over 3. H and h of x, or excuse me, x and h of x in point 0, 2 pi over 3 pi, 4 pi over 3, and 3 pi over 2. And again, feel free to pause the video, use your calculator, find your values, and then find your maximum and your minimum. Filling in your chart values, you get -1, 1.25, 1, 1.25, and 1. So your minimum is -1 and your maximum is 1.25. Remembering when you deal with natural logarithms that your value here must be greater than 0. It can't equal 0. So what would make this 0 would be positive and -3. +3 is inside of your interval. So f of x is not continuous. On closed -2 to 5. Since the domain of f of x is undefined from -3 less than or equal to x less than or equal to 3. So the EVT does not apply. All right, so taking a look, we have a cubed root of x minus 2 squared on 110. So this is x minus 2 to the 2/3 power. So h prime of x, bring down -1. So that's 2 over 3 times x minus 2 to the 1/3 power. So h prime of x doesn't equal to 0 because the numerator doesn't have a variable. But h prime of x does not exist when x is 2. So into our chart, we have 1, 2, and 10. Plugging in 1 gives us 1, plugging in 2 gives us 0, and plugging in 10 gives us 4. So we have a minimum of 0 and a maximum of 4. So keep in mind, we've been able to find these extrema just based on the information that we are able to gather from the equation and from the interval that is provided for us. So this proves that a graph is not always necessary, but a graph can help prove that what you have found is indeed correct. This is the end of section 2. I hope you guys have a great day and let me know if you have any questions.